All right. Thank you guys for allowing me to speak today, and hopefully we can answer some questions at the end. But like Jackie said, my name is Chris Friedman, and I'm with Irrigation-Mart, and we're going to talk a little bit about irrigation options for orchards and a few other things. So we're going to have an introduction. Why we should irrigate, things we're going to talk about, design considerations, commonly used products, a cost study that I'm pretty excited to share. I always like sharing this cost study. And then, of course, at the end, I'll take any questions and hopefully can answer those for you. If you guys are not familiar, I want to kind of introduce not only myself, but the company that I work for. The company that is Irrigation-Mart, and we are in North Louisiana. We were founded in 1978, and we grew now to 3 locations with over 50 employees. We have a lot of certified irrigation designers on staff, registered engineers, TSPs, crop consultants, and we deal with all the major suppliers in the industry. We have a pretty large warehouse in Ruston and can ship anywhere pretty fast. Why we should irrigate. Pecans have a high water requirements, and I'm sure you guys have been told this over and over again. 60 inches of total water during growing season. Now that's growing season, not the year. So that's April through October. The state of Arkansas, I just pulled the rainfall for Little Rock, is 49.56 inches in a year, on an average year. So that's 12 months, not during our growing season. So we have to think about that. We don't get our rain when we need it and when we want it. We get it in torrential downfalls in the wrong times of the year. So, but a mature pecan orchard may require 3,600 to 6,000 gallons of water per acre per day. So that's 1 to 2 inches of water a week. In peak season, an orchard's going to require maybe more than a half an inch. So that's a lot of water that it needs. Drought stress can affect the nut size and the nut filling, so the quality of our pecans. During the nut sizing period, which is May to August, if we have severe drought or don't have rain or adequate irrigation, we'll have very small nuts and we can actually have fruit split. So we want to make sure we have irrigation or at least some rainfall during that time. Drought during to mid-late can cause nut fill issues. We have poor nut fill and poor quality. So this right here, this slide is kind of showing the drought stress on a couple of different varieties. As you see, as the increasing drought stress, the pecans are getting smaller. And also, I'm sure the nut fill in those would be very poor and the quality of those pecans would be poor. When we talk about irrigation, this is kind of a typical layout. We're going to need to know our water source, and we're going to have a pump, we're going to have filters and different ways of applying that water to the field, whether it's drip line, drip tape, sprinklers, so forth and so on. One of the things I do want to note that irrigation is a key to having consistent yields. So a good irrigation system needs to be designed and laid out properly. Some of our design considerations, again, are going to be our water source, our tree spacing, our budget numbers. Is there any pests that we need to worry about? And of course, the customer itself. When we say the customer, is that customer going to want fully automation with moisture monitoring and controls that they can work from their phone or their iPad? Or do they want just a simple turn the pump on, open a ball valve or a gate valve to irrigate their system? A lot of irrigation systems in Arkansas, where I deal with most of the customers, are very simple, bare bones irrigation systems, but we do have a few customers that want it fully automated and can access it wherever they are in the world. Again, some of the key considerations is our row spacing and our tree spacing. And we see in pecans, we see high density of 15 to 30, all the way to trees being spaced out 65 by 65. And it just depends. It's all over the board. Different orchard owners have different ideas. I will say on our high density spacings, we are going to need to know, are you going to go in and eliminate trees in the future? Are you going to be thinning? Those are things we need to consider when we're doing our irrigation design. We need to know that for the future. Also, we're going to need to know which way are you going to be running your equipment, so we can keep that irrigation out of your rows when you're running your harvesting equipment or your mowing equipment. If you're going to have a herbicide strip, those are some things that we need to know right up front. Another key factor that we need to know is going to be our soils, where your orchard is. If you have a sandy soil, that water is going to drain faster than a clay soil or a loamy soil. So we need to know that. And that's going to be something that we really think on, what products we're going to use in your orchard, depending on your soil type. We may have lower flow rate emitters or tighter spacing, or we may not use, or we may use impact sprinklers or other different products depending on your soil. Another key factor is pressure considerations. We're going to need to know your tree row lengths. We're going to need to know where your main line is going to be, your lateral lines, and also elevations across that orchard. Most orchards in my area of the world are kind of in river bottom, so they're kind of flat, so we don't have a lot of terrain change. But we need to know if there's a lot of elevation change across there. That's going to be a key factor when we start laying out pipelines. And again, we need to know which direction you're going to be harvesting and running equipment. Filtration is a key factor in all irrigation systems. And when we talk about filtration, there's going to be about 3 major types of filters that we use, especially in pecans. You're going to see either screen filters, sand filters, or disc filters. Sand filters are going to be your best filtration device, and we use a lot of sand filters in surface water applications. The downfall to a sand filter is they have a very large footprint. And you see in this bottom picture to the left, those big stainless tanks, that is a sand filter set up for a small pecan orchard that's actually made on a trailer that's going to a customer. So he can pull it to the riverside, hook up to it, use it, and then when they're not irrigating, they can pull it to the barn and park it for the winter. But as you see, that's a huge footprint there just for 500 or 600 gallons a minute. And that's also a cost. And then you're going to have on the bottom end, you're going to have screen filters, like in the top right corner. Most of these are going to be used when we have very clean water, or maybe a product that has a large orifice that we don't have to worry about maximum filtration. We're just putting it on a well. Maybe it's a pretty clear, clean well, and we're just going to catch sand or gravel, things like that. They're not going to be the best filter, but they are the most cost effective in some applications, and they're not very expensive, and they have a very small footprint. And somewhere in the middle, you're going to have this bottom right picture. These are disc filters. These are getting to be very common. We use these a lot in a lot of different irrigation systems. They have a smaller footprint than a media filter or a sand filter, but they're just as adequate as a sand filter. Most of these are going to be automated, because as you see on that skid down there, there's 3 valves that are going to backwash and flush those pod banks, which are the gray pods there that you see. Those are the filters themselves. And this is a pressure regulating valve to the left of all that, and a flow meter. This is actually set up on a pallet, and this went to one of the pecan orchards in Oklahoma that we designed for them. So let's get into some of the commonly used products. Drip line is a commonly used product in a lot of our area, the Southeast. Typically over in Oklahoma, they use a lot of drip line on pecans. You guys may see drip line a lot in blackberries, blueberries, and other orchards like that. Great thing about drip line is it can be put above ground. It can be plowed in. It have multiple spacings, multiple flow rates. It can be pressure compensating, non-pressure compensating. You can have just a solid tubing where you punch in your own emitters. That's what they do a lot of time on vineyards. or you can get the tubing that already has the emitter built into the tubing at different spacings. Some of the advantages, of course, are there's less disease and insect pressure because we have less wetted area. We're not throwing water where we don't need it, so that can restrict the population of some of our potential hosts. There's no effect by wind or solar, so you can irrigate at all times. You can irrigate while your equipment's in the orchard. You don't have to worry about being sprayed or anything like that. And of course, it's very easily adapted to automatic controls, and we can fertigate and chemigate through drip line, which is a big plus for drip line. Some of our main disadvantages of drip line is, of course, we need clean water. There's a very tiny orifices in these emitters, whether they're a plug-in emitter or emitter made into the drip line themselves. There's very tiny orifices, and they can get clogged up with algae or any bacteria or whatever you have in your line. So we need to make sure our water source is clean. We have adequate filtration. And in some areas, we may even have to chemigate just to keep our water lines clean and clear and our emitters flushed out. And so that adds a little bit of maintenance to your irrigation. Clogged emitters, like I was saying, from poor water filtration or algae, bacteria, sulfur, iron, calcium. In Arkansas, we have, I know I'm going back to Arkansas, that's where I run most of my areas, Arkansas and southern Missouri. We have a lot of iron bacteria in our water, so we don't use a lot of drip line in pecan orchards because it adds cost to managing that water and that filtration system. You'd see more sprinklers and above ground irrigation, which we're going to talk about in future slides, in our area because of the bad water quality, the algae, the bacteria, the sulfur, things like that in our water. Drip line on sandy soils can be very hard to get that water to move uniformly. It wants to drain down, but we can tighten up some spacing and do some different things with our drip line if we have sandy soils and we want to use drip line. Another thing is mice and rats. They love to chew drip line in half. They will dig a hole and chew that stuff, and you'll have to splice it back together. But the good thing is it's very easy to couple, and usually it's very easy to find where the rodents have chewed a hole in it because you'll have a big puddle compared to the rest of the orchard being pretty dry when your irrigation system is running. And if some of you guys don't realize or know, drip line is just a polyethylene tubing. It's very flexible, and it's easy to cut or for rodents to chew through. But on top of that, it's very easy to couple back together. They make several different kinds of couplers, and it's very easy to put the tubing back together. Usually the most common ones is like a power lock fitting. You screw two nuts backwards, slide the tubing up on the barb, and tighten the nuts down, and there you go. It's put back together. Another thing we use a lot of in orchards would be sprinklers. And when I say these sprinklers, like these are going to be brass impacts or maybe even big golf course heads that have large orifices, and they're going to have high flow rates. They're going to have large radius of throws, and they're going to be very durable because they're going to be made out of brass or high impact plastic. And they have large orifices again, so it takes very little filtration for them. They're very easy to install. Most people understand these. They're in a lot of everybody's gardens already or in their yards. Again, minimal filtration is required, and they're very durable. The disadvantages of them is there's a high operating cost because due to their high pressures and their large flow rates, that's going to be bigger pumps, bigger pipelines. So that's going to add to our cost of our orchard. And you're going to have high disease pressure because we're throwing water around in the air. So you're going to have water just everywhere. You're going to have puddles of water and things like that. They're not very good in uniformity or efficiency, again, because they're affected by wind and solar, and they're throwing water through the air. So another commonly used product is micro sprinklers. These are very common through my area. These are going to be on a stake. They can be PC or non-PC. They have deflector tabs, and they can be insect resistant. The deflector tabs on these micro sprinklers, all it is there's a little spinner, and that tab it hangs off the side of that spinner and it knocks that stream of water down. So when the trees are small, they'll throw a wetted pattern of probably about 7 or 8 feet. And then when the trees get larger, you break that little tab off and that sprinkler can throw the water pattern that it's made to at its full capacity. So that could be anywhere from 13 to 30 feet, depending on the sprinkler and the height of the stake. And when we say they're insect resistant, the way they're made is, again, there's a spinner and there's a cup on that sprinkler. When that spinner when there's no water coming to that spinner, that drops down inside that cup. And that keeps spiders and slugs and things from building up in the orifice where the water comes through on that sprinkler. If you get one that is clogged up, whether it's algae or sand or insect, you can usually pop these off very easily, and that tube of water is still going to be come to that sprinkler, and that stream of water will be shooting up, and you just turn that sprinkler upside down and wash it out and screw the sprinkler head back on. So advantage of these sprinklers, they're going to have lower operating pressures than our larger impact sprinklers. They're going to have lower flow rates. They're going to be gallons per hour typically instead of gallons per minute like our large sprinklers. They're very easily adapted to automation. And again, we can fertigate through these sprinklers. Some disadvantages of we need to make sure our water supply is clean. We are going to have a little bit better filter than our larger sprinklers that have larger orifices. And you can have clogging heads and rodent damage because there is a micro sprinkler that feeds this sprinkler mounted on a stake, a micro tube feeding the micro sprinkler on the stake. I have a lot of customers that will buy a few extra of their micro sprinklers. They're very inexpensive. They're usually just a couple of dollars a piece. And what they'll do is they'll buy an extra 50 of them and they'll keep them on their side by side. And as they're riding around through their orchard checking, if they have a clogged sprinkler head, they will just pop that one off of the stake, throw it in a bucket, put a clean one on, and then on a rainy day, they'll clean up those stakes or those sprinklers that are clogged up. You can take a little bit of mild acid or CLR or something like that and clean those sprinkler heads up. And again, put them back on your buggy. And as you're riding through the orchard and you see clogged ones, you just swap them out. Jets is another product we'll use. They're very inexpensive. There are no moving parts to them. There's basically just a stream of water that comes up and hits a deflector tab, and that creates the pattern that they're throwing out. But usually their jets are small diameter in spray. They have minimal misting. They take lower pressure to operate, and we can fertigate through these sprinklers. Kind of beating a dead horse. We need to make sure that we have clean water supply, adequate filtration. You will have clogged heads with these jets. They have a tiny orifice that you can just wash out again, or take a little needle and clean out, or soak them in some CLR or vinegar. They can be damaged by rodents because they have a microtube and feeding them. That's kind of the different things we will use to irrigate a pecan orchard. And then I've kind of got this irrigation study here that was done a few years ago that I like to really use and show you guys, because it kind of puts, feet to the fire and money. You can actually see the money that the irrigation system provided after installing it. So in this study, the system parts and installation was about $800 per acre. The well, a 4-inch well of 5 horsepower was about $7,800. A 6-inch well with a 30 horsepower was about $34,000, and the operating cost was about $40 to $60 per acre. In a lot of the designs and a lot of the orchards that I've helped lay out, $800 per acre is about middle of the road. I have seen as low as $600 per acre, and I have seen as high as about $1,500 an acre. And again, that goes back to how automated this system is, what our water supply is, and what our filtration needs to be, and what sprinklers we're using. $800 per acre is pretty good middle of the road. So on this study, they had a section that was unirrigated, and the yield was 1,034 pounds per acre. And then they had a section that they put 1,200 gallons a day per acre on, and that's about 3/10 a week. And so, and the yields on that section was 1,374 pounds per acre. So that's a 32% increase at a value of $455.60 per acre. And then another section, they put 3,600 gallons a day per acre, and that's about an inch of water a week per acre. And they had a yield of 1,761 pounds. It's about a 70% increase of a value of about $974.18. They used Stewart's on this study, and at that time, those were $1.34 a pound. I think today they're around $1.40. So that's a pretty good number when this study was done. So again, we're assuming $1.34 a pound on a 25-acre orchard. The cost of a new irrigation system was $27,800. The value of the increase in production was $974.18 per acre times 25 equals $24,354.50. So if we took that $24,354.50 away from our $27,800 that it cost us to put that irrigation system in, you have $3,445.50 left to recover in the second year. Now, one thing I'll note about those numbers is that does not include any of the management costs. So we said $40 to $60 an acre for management costs in there of the irrigation system. So, you know, still you're under $5,000 to recover in the second year with that management cost. Now, if we took more like a desirable or maybe a Pawnee, a little bit of pecan that made a little bit more money at $2 a pound, that value increase is $14.54 an acre. So you do that times 25 acres, you get $36,350. You take that away from your $27,800, you're actually a positive $8,550. So you made money the first year off the irrigation. So that same study they did on 25 acres, they did it on 100 acres. And again, assuming $1.34 a pound, the cost of the irrigation system was $114,000. The value was $974.18 per acre times 100. That's $97,418. You take the $97,000 away from $114,000, and you have $16,582 to make up the difference in the second year. We went with a more desirable pecan. You actually would make $31,000 the first year of using your irrigation, because at $2 a pound, we're at $145,400. We take away the $114,000 it costs for the irrigation system, and we end up a positive $31,400. So that kind of comes to what, you know, a conclusion of what we say. Irrigation is a necessity, not only for constant pecan production, but it provides the most immediate results and the fastest return on investment in virtually any management practice you can use. And water is key to the important process involved in development of pecan crop.